All right, real quick, just a review from yesterday. What's the theoretical probability I roll a 4 on a die? 1 out of 6. Okay, that's what should happen, right? Theoretical probability, what should happen. All right, now we're going to find that probability of rolling a 4 based on a experiment that you're about to do right now. So everyone, if you could go to a web browser and type in roll-dice-online.com. And again, I don't have 20 plus die to give everyone to do this. Plus, it goes pretty quick. It's a lot quicker this way. Okay, so once you get there, you're going to make sure you have a 6-sided die. You're going to roll it once, 10 times. Okay, 6-sided die, number of dice to roll, just 1 die, and then you're going to do it 10 times for me, so you can hit everyone roll dice. And in that chart that I have for you here, you're going to write what numbers came up all 10 times. All right, so write what numbers came up for me on your own, not mine, not the person next to you, on your own. And I want you to find now your experimental probability of rolling a 4. So how many 4s came up out of 10? That's going to be your experimental probability. And then just quickly, look around, talk to the people next to you real quick, see if they got what they got. Was it the same as yours? Was it not the same? Let's do a quick class poll here. Look around, see what they got. A lot of different ones. Okay, yeah, that's fine. That's just what's expected. So now we're going to do it as a whole class now. So I'm going to take however many 4s you got, and we're going to make it into a quick little graph called the dot plot. And we'll see what the class probability. You have your own probability. Now we're going to do a class probability. All right. So real quickly here, I don't know, have you seen a dot plot before? Here, like one of these bad boys. Okay, we're going to set one up as a class right now. So on the bottom, on your x-axis, that's going to be the number of 4s that everybody got. And on the y-axis is going to be how many times it occurred. Frequency. So how many times did we roll the die? 10. So on the bottom, I'm going to 1 all the way to 10, because who knows, maybe somebody got all 4s, all 10 rolls. Doubtful, but it's possible, right? All right, so what I'm going to do right now, I'm going to go around to each one of you, and I need you to tell me and your classmates how many 4s you got, and we'll plot it up here. All right? Anybody go above 5? Okay. Okay, everyone ready to fill it in? I'll go first. I had 2. So everybody at 2. There we go. I got 2 4s, so there's at least one of us. Here we go. Brett, let's go. How many? I should I should probably also put 0, right? Because it's possible. Brett, go ahead. Sorry. 1. So we got that one there. Yep. Let's keep going. Sarah? 1.
I got 0.
0. Maddie? 3. There we go. 2. 0. Might have to go above 5. Nick, 1. 1. 4. There we go. 2. 1. I have to increase this here in a second. 2. 1. Mary, you said 1, correct? Okay, so now we're up to 6. 2. 1. 7. 3. 5. Always that 1 in the group. 3. All right. So now let's find our probability we get a 4. Let's see. First, we got to figure out how many times we rolled total. Each of us rolled how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So how many total rolls here? 190. So out of 190 rolls, now looking at our dot plot, how many 4s did we get? How many 4s did they come up? So right here, that 0 4s came up here. How many here? Let's see. 1, 2, 3, 4, 5, 6, 7. Remember, how do I count this one now? 2, 4, 6, 8, 10. 4s came up there. 9 here. 4 here. 5 here. So anybody want to add that up real quick? And how many total 4s did we get?
35.
30.
5.
35 out of 190. That's our class total now. Now I do this for one reason. 35 out of 190, that's about what percent? Anybody calculate that for me? 35 out of 190 on your calculator. It's about what percent for me? What is it? About 18%? So as a class, about 18% chance we get a 4 on the next one. We get a 4. What's the theoretical probability again of getting a 4? 1 out of 6, which is what percent?
17.
What is it?
Well, 1.166.
So about 17%? Pretty darn close, right? Pretty darn close. Versus if you take the one, like if mine here, what's 1 out of 5? Anybody know as a percent? What? 20%. And that was just my 10 rolls. What am I trying to get at here, guys? The more and more and more trials you do, what's going to happen to the theoretical and the experimental probability? It's going to get more accurate. They're going to come closer and closer together. Mine was 10 rolls. I got 20%. Then we did 190 rolls, 18%. If I had you do it again and again and again, this number is going to get closer and closer and closer to the actual 17%. Okay, so the more you do, the more trials you do, the closer the experimental comes to the theoretical. We all good there? Yes? Okay. I don't know. I always find that interesting. I know you guys probably don't, but you guys have a conclusions here, correct?
Yeah.
Okay, so what we just found out, the more trials, you can put simulation in parentheses. The more trials that occur, the closer the experimental gets to the theoretical. Okay. It didn't happen on the first 10, but as I added up 190 different rolls, it got closer and closer. We pick up on that? Anybody think that's neat? Probably not. Okay, fine. I'm on my own on that one.
I think
Okay. Yeah. We good? All right, now let's keep going. I did a bunch more experiments for you, and I want to find the probability based on those experiments. Movie theater. Here's where these were the age range of the people coming out. I asked them for their age, and I tallied how many there are. So there was 13 0 to 7-year-olds that came out. Okay, 28 8 to 12-year-olds that came out. What's the probability you select somebody who's older than 12 but younger than 46? So the first thing we need to find is how many people fell into that category. Older than 12, younger than 46. Do you see the numbers we're going to add up?
Yeah.
So what's the first frequency we should be taking? 13 to 17. So I have 48. Do I take 18 to 23? Yep. 24 to 31. 32 to 45. 46 to 64. Nope, I stop right there. So what is my total number of people that fit in this age range? 1. 4. Oh, that's the common rookie mistake. There's not 4 people. There's 4 age ranges. How many people are 13 to 17? So there's going to be, how'd you get it? Had to add them. Everyone see that? Okay, you just don't tell me how many age ranges. I need the number of people. So what was it, 157? And what always goes on our denominators? The total number of people coming here. Okay, not the total number of age ranges, total number of people. Here we go, 3. Take your time. 200, and I don't have my key in front of me, so I'm trusting you. Yes. How's that look? 157 out of 254. Going? All right. Oh, here it is, finally. I got to do the test your knowledge first. Cards. 4 suits. Actually, I don't have to do it here because we're doing it based on the experiment. I will have to do it coming up here in a second. Experimental probability of drawing a heart. So this is what he did. What's the probability he drew a heart? Experimental, not what should happen, but based on what he did. Here you go, 16. Do we have a 16? All right, Rachel. How many hearts did he draw? 5 out of how many cards total? 25, yep. So if you guys want to give me 1/5, that's fine too. What about black card, based on his experiment? 18, don't have one, I don't think. 4?
That's me.
Great,
Black
great.
card. Am I not?
Oh, all right. Fine, it was something we have to go over. What a black card.
I'm not a card.
That's fine. I have no issue.
Okay.
All right, I have no issue. Maybe 10 years ago when I taught this course, we'd all laugh at you, but as time has progressed, nobody knows cards, and I understand that. Okay, cards, here we go, everybody. Ready? Let's talk about the deck. How many total in the deck? 52. A little tree diagram for you. Half the cards are black. 26. Other half are red. 26. Okay, the black cards are made up of 2 suits. There are 13 spades.
What's that supposed to mean?
13 clubs, pieces of broccoli or trees, whatever, right? I'm sorry. That's why I teach math and not art. Next one over here. You have 13
Heart.
hearts, 13 diamonds. Okay. Live it up. All of them, all 4 suits have the cards 2 through 10. Jack, Queen, King, and an ace. Okay? That's where the 13 cards come from. Yep.
Do you see an ace as a one or like a more than?
It's just an ace.
No, like but you
It's just an ace. Just an ace. Okay, we good?
Yeah.
Marissa, we good?
Yeah.
Okay, so going back to the question now.
26 out of 52.
No. That's theoretical probability that you just gave me. Based on his experiment. So you're thinking black card would be clubs and spades. How many are those?
16.
So 16 out of the 25. What you gave me was the theoretical. Okay, we're just going based on his experiment. Good? Everyone else okay so far? All right. Now what he did it again and combined his results. Okay, that's what part C is saying. Jim repeated his test. The results of the second test are shown below. Please combine the results now to answer these questions. What's the probability of drawing a black? Theoretical probability. Theoretical, which means what should happen. Standard deck of cards in front of you. What's the probability you draw a black card out? Not from his experiment. 8. How many black cards are in the deck? 26 out of 52, so 1/2 shot, right? 1/2 your probability. Find the experimental probability. You drew a heart now. Remember, you're combining both. Combine both charts for me. Experimental probability, you could draw a heart out. Okay, so 14. How many hearts from both experiments did he draw? 11 out of, now how many cards total did he? Knew it was 25 up top. I believe it was 25 again, right? So 11 out of 50. What? That's what I thought. Find the theoretical probability of drawing a heart. So what should happen now? What's the actual probability, not from his experiment, but just drawing a heart from a deck of cards? All right, 1 has a heart from the deck of cards. 13 out of 52. Explain the results. Well, quickly, 11, what percent? About 22%. And 13 out of 52 is exactly 25%. Okay? Remember up above. Hey, remember up above, what was his experiment in part A? What was his percentage of drawing a heart here? 1 out of 5 is what percent? You can leave it there now. So you guys tell me. It went from 20, and then all of a sudden he did another one, and now it went to 22, when the actual one's 25. So why did it start creeping up again? Why did it go from 20 to 22, which is getting closer and closer to 25? More trials, closer it gets to theoretical, yes. And that's the big thing for today. More trials, the experimental gets closer to the theoretical. Okay, and I think that's it. Yep, perfect. That's all you guys have, right? Correct, and then it goes to the homework. Okay, Chromebooks are already out. Perfect. Grab the answer key to today's assignment. You got 20 minutes, half the class here. Let's go.
Carlino, what's the best thing that you can draw? Best thing.
Oh my, that's that without a question. That's not even a name. Oh, That's too easy.
Dude, that shows up.
What are you doing?
I'm answering your question.
What is that?
What? Like a spark?
No, it looks like it's a firework. Yeah. Is that a mask? Definitely first. Wait, it's a tiki bar. Is it? No, it's a house. I was right. The first one. Because it's got little shingles in it. It's got like little shingles. Is that like shingles? No, but the top.
Symmetrical hot dogs, Dan.